So thanks for attending. I know this is the last session of the day, so you can have some rest, if this is the place that you were looking for before the party. It's okay, I will not judge. So the session will be about SUSE Multi-Linux Manager and the container images. It's an unknown feature, and I was not aware of this feature really before trying to do this session. So I'm Gaëtan Trélu. I'm a solution architect. I'm located in Canada. I will not give you the city. I put some Easter eggs inside the presentation, so you're going to have to pay attention to know where I came from. Oh, okay. So I will know if you didn't pay attention. So. This is the agenda. So we're going to quickly go through what's about SUSE Multi-Linux Manager, which got renamed. So before that, it was SUSE Manager, and then SUSE Multi-Linux Manager. So for short, that's going to be complicated, I guess. Next, what's a container? Just to make sure that we are all on the same page. Container versus container images. SUSE Multi-Linux Manager as a container image builder. SLE BCI, again, you're going to have to wait to know what it is, and a demo if we have time and if it works. What is SUSE Multi-Linux Manager? Again, I'm not going to spend that much time on it, because if you are here for the container image feature, it's mostly because you know what SUSE Multi-Linux Manager is, but it's one of our products that allows you to manage multiple Linux distributions. So not only the SLE distribution, but Red Hat, Ubuntu, etc. We're going to go further on that later. Basically, this solution will help you to manage, to patch, to audit, to deploy, secure, configure, etc. And yeah. I don't know if you attended the SUSE Manager roadmap, but Don basically mentioned that they had some deployment going up to 100,000 clients. We can do more, probably. I never saw that, but that's going to be fun to see. Then, so the distributions managed by SUSE Multi-Linux Manager. So of course, all the SLEs and OpenSUSE flavor, so SL Micro, OpenLeap, etc. Of course, CentOS, Red Hat Enterprise Linux, which are part of the SUSE Multi-Linux support. Again, if you attended some session today about that, that's basically Liberty that got rebranded, and we are now fully supporting and providing supports for people that has this Linux distribution. So instead of calling the red team, you're calling the green team. Rocky Linux, Alma Linux, and then Debian, Ubuntu, Raspberry Pi OS as a tech preview. So it's not fully supported, but it's going to be there with 5.1. By the way, we are at 5.0.3, so be patient. Amazon Linux, Oracle Linux, Micro Focus, and I think I missed probably Alibaba Cloud. And yeah, Debian will always be my first. So started 22 years ago with it, and I still have some running at home, especially because I have a lot of Raspberry Pi around. So for those familiar with Raspberry Pi, you know that the base OS is a Debian, basically. So what's a container? So you will see two different things here. You will see my definition, and you will see the definition of SUSE AI with Mistral model. So container basically are portable software package, including all the dependencies. So I'm not gonna read the definition. You can do that by yourself. But basically, a container is a container image is a self-sustainable image that contains all the libraries, all the code, etc., that you can deploy everywhere, depending, the Linux distribution, etc. And this is the SUSE AI definition with a friendly persona. So let me know which one you prefer. So, I just hope you don't prefer the SUSE AI one, because I'm going to lose my job, I guess. Container versus container image. So there are two different things. A container image is the roots of a container. So you are not deploying a container image, you are deploying a container. So a container is basically a runtime instance of a container image. And then again, the SUSE definition. So far, which one did you prefer? The mine or the one from SUSE? Don't be shy. SUSE. Oh, that's a nice answer. I don't know who did that, but that's a nice answer, so thank you. This is the definition of, this is an example of a Docker file, a very simple Docker file. This is what you will be able to see, if you browse on Google, like, hey, show me an example of a Docker file. So Docker file will be used to build your container image. And as you can see here at the top, I'm referencing what's going to be the base image of my container. So here I'm going to use an image coming from SUSE registry, and I will go on that later, which is part of the SLE BCI that I didn't mention what it means yet. You're going to have some argument. This is not a requirement. It just depends of what you need inside your image. If you want it to be a bit more dynamic than just static, you can pass variable via the arg capabilities. Then you're going to have the labels. Labels are more as best practices from the OCI Foundation. So it just gives information about the image. And depending the registry that you are using or the tool that you use to deploy the container, you will get the information via the, for example, Docker image, info, etc., about the image. But when you use a registry, this kind of information can be displayed directly on the page. So we specify the author, when it has been created, a description, documentation, sources, vendor, and version. As you can see, I set default value for version because I'm not planning to pass any version in this demo. The work there, again, what's the home directory of your container? And then we have I would say, the first interesting part of it, which is what do you want inside your container? So here you can see that I'm running basically 3 commands. So 2 zipper command and 1 pip and start command. So the zipper is installing one package, which is libopenssl. The second one is based on a bash condition, based on the first argument at the top, which means that I want to install a package from PyPy, either from the alpha releases, so non-stable, if you want to do some testing, lab, etc., or you just want the stable version available on PyPy. This is basically what the if condition does. And at the bottom, I'm just cleaning, everything, making sure that I don't have any downloaded packages, because basically, since I install libopenssl, I will have at least 1 package in the cache. And the last command, so the second most interesting command, it's going to be basically when you run the container, what's going to be the command that's going to be triggered. That can be overridden by an entry point, but if you don't provide any entry point during the container creation, you can specify this directly in the image, which means that every time that you will create a container based on this image, if you don't define entry point, that will be the command that's going to be run. And this is basically just a fast API. So for those that are not familiar, it's just a Python framework to build API. So nothing fancy. So now that we know how a Docker file looks like, we should be a bit more familiar. And again, it's not just me speaking for 50 minutes. So you can just interrupt me, ask questions. That's going to be fine. I'm not going to be pissed if you are just stopping me right in the middle of a sentence. It's a safe zone, okay? So now that we know what SUSE Multi-Linux Manager is, now that we know what's a container and what's the difference between a container and a container image, why use SUSE Multi-Linux Manager as a container image builder? So basically, if you don't have SUSE Multi-Linux Manager right now, don't install it just to do the image builder part. It doesn't make sense. There is other tools that does that natively, and doesn't make sense. but if you are already using SUSE Multi-Linux Manager to manage different Linux distribution in your SE, in your Linux, in your in your environment, that's going to be one way to build the container image. So why to do that? The manager, I will reuse what Don Vosberg did, just mentioning manager instead of SUSE Multi-Linux Manager, because that's going to be painful at the end. But the manager will be able to connect to multiple registries. So you can configure Docker Hub, SUSE registry, your private registry if you want. Which means that, for example, if you are using a private registry such as Harbor, you will be in full control of it, which means that you will be able to, scale the registry, add authentication, add some scanning capabilities such as 3D, etc. An automated build process, in a sense that SUSE, the manager has many APIs available, which means that you don't have to just go on the UI, click and build, etc. If you have an external automation, you can just trigger the SUSE Multi-Linux Manager API to trigger a build, to create a profile, to create a store, etc. And I will go a bit deeper on that later. So the next one will be compliance and security, which is, in my opinion, one of the most important feature of this solution. It's when you build an image, you define an activation key to this profile. This activation key can be either the default channel, default base channel, or it could be a lifecycle management that you build, and you want to make sure that the container image that you are using follow the versions or the packages that you have defined in this content lifecycle management. So that's going to be the basic container architecture. That's very standard. So in order to build container, you need a Docker client. And one of the limitation right now is that it only works with Docker. I hope to see in the roadmap some Podman capabilities or some other container engine, but right now it's Docker. So this is why the slides are going to be labeled with Docker. So Docker client to pull, build, run, and then you're going to have the Docker daemon. So it is the host where you basically run the build, pull the image, push the image, and create the containers. And of course, to do that, to pull an image or to push an image, you need some registries. And here I didn't put Docker because you have many ways, as I mentioned earlier. So you have private registries, or you have you have Quay, you have Docker Hub, you have again SUSE registry, but you have many of them. So you can use Google, you can use GitHub as well. So that's the basic container architecture. So now, when you include SUSE Multi-Linux Manager into it, you can think of it as you replace the Docker client by SUSE Multi-Linux Manager. It's not fully like that, but it's to simplify how to see the architecture. So you will have SUSE Multi-Linux Manager as a client, and this client, based on UI, UI click, or API automation, etc. This client will trigger a build, and this build will happen on a Docker host or on a container host, which is registered within SUSE Multi-Linux Manager. So you will have your SUSE Multi-Linux Manager, and then to achieve this architecture, you will need to define a dedicated host that will be registered as a container host within SUSE Multi-Linux Manager. And I'm going to demo that later. So the main difference here, of course, the client, but we are not speaking directly to the Docker daemon anymore. We are speaking to the salt minion agent installed on the container host. And this is this agent that's going to speak directly to the Docker daemon itself. And after that, it's the same, basically. So you define which registry you want to pull or push your image. Are you good so far? I see some that are snoring already, so no? It's okay. Questions? No? Okay. So now what, what was SLE BCI? So it stands for SUSE Linux Enterprise-Based Container Image. Whew, that was a long sentence to say, but what it is, it's our own registry. So you will have enterprise container images available there. So which means that instead of using Docker Hub, which potentially will have images not certified or built in a specific way that you don't know which packages are inside, when it has been, you can see when it has been built, but the SUSE registry will provide basically security. And you don't need any subscription to use that. So right now, if you are not a SUSE customer, but you just want to use business, I would say enterprise container image, you can do it. You don't need a subscription for that. And as mentioned here, you can redistribute the image. FIPS, so it's a standard. And if your hosts, if you are running, for example, K2 with FIPS enabled, and you are provisioning a VM on this kind of environment, the container will automatically, flip into FIPS compatible to make sure that you follow the FIPS compliance. That's one of the main reasons why you will be able to do some scanning with SUSE Multi-Linux Manager and these images. It's because the RPM database is going to stay inside the container, which means that with this capability, the minion, so the sort minion, will be able to connect inside the container, retrieve the information from the RPM database, compare which version has been installed to a CVE list, for example, or a patch list that we have available within SUSE Multi-Linux Manager. So that way, you know if one container is vulnerable or has some bug fix available, etc. And the last, and I just put the 4 main bullet points, but you have a full link at the bottom that gives many more information about why use BCI. These are just a tiny bit of the highlights that it will provide. But you will be able to register, a container directly to SCC. So that's an example of, and these screenshots are from yesterday. So this is an example of an image that runs basically Python 3.12 coming from BCI. You can see that the vulnerability reports, it's basically 0. So you don't have any CVEs, either critical or just warning, etc. So 0 CVEs. And you can see that yesterday the scan happened 21 hours ago, which means that it's running every 24 hours. So now this is the same image, so the same main image available on Docker Hub, and this is the vulnerabilities that you have. You can see that this one has been built 11 days ago, where the previous one has been built 4 days ago. And you can see that, you can see the differences, basically. You have many, I wouldn't say many, you have vulnerabilities, you have warnings, and it looks like, like this, like a Christmas tree, except we don't have any green, which is a shame. Then we have the demo. So the demo is gonna be here. So it's gonna be on SUSE Manager. So I'm gonna provision a build node. Oh, the build node is already provisioned, so that's okay. So I will provision a new one. So SMLM. So far, were you able to determine what was my city, from which city I came from? Nice. So let's go for 8 gig. And by the way, this is SUSE virtualization. So, we are consuming our own software. And let's go on the flat network here. And let's make it just UEFI and create. It's going to be provisioned. And I'm not going to wait for that. I already provisioned the VM build 2. And Is it big enough? Okay, maybe that's going to be better. Okay. So I already provisioned VM build 02, which I will register into SUSE Multi-Linux Manager. So I'm not going to do that via the UI. I'm doing that directly with a Bootstrap script, which is easier for me. I prefer that than just doing the ClickOps. And then at some point, it's going to be available here. So you can see that I have a backup plan already, just in case. I have one host that is already provisioned with the right system type. You can see the system type, so let me just increase a bit here. Is it big enough? Yeah? Okay. So by default, when you register a node within SUSE Multi-Linux Manager, you're just going to have, the salt type. Here you can see the main difference is that I have the salt type, and I have the container build host type. What it means is that this host has been identified as a build host for container. And this is, when I'm going to trigger a build, this is one of the hosts that's going to be available to receive the Docker build command. So let's see if the second host, no, it's not there yet. Maybe it will never show up. So let's just check. Oh, okay. So I guess I'm gonna have to accept the key here. Oh, newbie mistake. Oops. Okay. Okay. So it was waiting for me to accept the key. So that's fine. So until it's coming up, I'm just going to show you what it looks like, how you can basically define a host as a container, so define a system as a container host. You can do that this way, or you can do that directly via the activation key. Here, I have been lazy, so I just wanted to have one activation key for SLE 15 SP6. But you can have, the key directly assigned to a type. So to change the type of a host, you can just go on so let's go back on the system list. You click here, and then you go into properties, and you just have to check the container build host, okay? So this basically will just say, hey, this host has to be a container build host, but it's not going to do anything until you go to the states and you apply the state. And basically the state will apply a formula which will install Docker directly on the host. So you don't have to SSH on the host and install Docker directly. That will be handled directly by sort itself. So, we have the second one finally showing up. So we'll see if it will be there on time. So now, the image part of SUSE Multi-Linux Manager is here. It's on the left menu. And to be honest, as I mentioned at the beginning, I didn't pay much attention to this feature until I had to do the session. But I was like, oh, okay, there is an image tab here already. So if you go on the list, you will be able to see that I have one image. I will go on that later. But to be able to get this image showing here, what you have to do is first create a store. So I have one store, but I will create, just a Docker registry store with my credential. So my boss is the best. My boss is in the room, so just help me to get a raise. So now I have two registries, okay? So now that I have a registry, I need a profile because I cannot build anything without profile. So my profile is going to be basically the container image, what kind of type. So right now we are supporting, either Dockerfile or Kiwi. This demo is about Dockerfile. So let's say SUSE-25. And I have to choose basically the store where I want to push the image that's going to be built. So I'm going to choose Harbor because it's nice to have a private registry. And then you have to specify a Docker file. So for me, it's hosted on GitHub, but if you want just host, oh, I think, okay. If you just, I think we lost, no, it's just me messing with the mic. So it can be hosted as well directly on HTTP server if you don't want to set up any Git repo. I don't know why you will not set up a Docker file on Git repo, but who knows, you know? So I will show you what the Docker file looks like. Again, you know, this is mostly the same as the one in the slides earlier, but just as a reminder, this is what SUSE Multi-Linux Manager will fetch and build the container with, build the container image with. And no, it's not here. So I specify the Docker file, and then this is the activation key. This is what I mentioned earlier. So right now I have two activation keys, one for the multi-Linux support, and the other one for SLE 15 SP6. But you might have a different one, which will be, for example, SLE 15 SP6 - container, which again will implies that when the host is going to be registered with this key, the Docker formula will be applied on it. But here, it's not about that. Here, it's basically the image, the activation key that you want to apply to the profile. So like that, you will compare what the image has been built with to this specific activation key. And then you can see here some custom info value. So the custom info value are the args that you saw earlier in the Docker file. So this is how you will be able to interact with this kind of variable. Okay? You can add, you know, many of them. It's not just one. It could be 1, 2, 3, 10, whatever. And then you can create it, and you will have a new profile available here. So let's see how. Yeah, the second node is there. So for example, let's just apply the container host build, update profile, and then as I mentioned earlier, you know, if I don't apply the state, it's not going to do anything. So I'm going to the state page and apply the states. And then if I'm checking, it's already picked up by the scheduler, and then you will see the apply high state. So if I'm checking here, yeah, you can see that the sort agent, so let me just increase that a bit as well. The sort agent already picked up the job, and if I'm checking for here, yeah, you can see some zipper command, already running at the top. So it's going to basically deploy, install, the container package. I don't know how long it's going to take. Yeah, it should not be long. So right now, if I'm doing sudo docker ps, yeah. So I have docker up and running. So now, if I want to trigger a build, I'm going into build, and I'm choosing which profile, the version, so the tag. So let's say 0. Let's go for this one. And the build host. So you will only be able to see the host that has the container host type. If you had like 10 hosts and 8 of them were just basic sort type host, you will not see them in this list. You will only see the hosts that has the container host type. So I'm going to choose, should I choose the first one or the second one? The 0 one, I know that it's working. The second one, I'm not sure yet. So let's go for the second one. And I'm going to blame you if it doesn't work. So you can see here, it's in progress. So let's do some refresh. Is it doing? Nothing yet. So let's do some sudo docker image. Oh, I got some image that got pulled. You can see that I have an image that got pulled 40 seconds ago. And OK, the image has been built. I'm surprised it worked first shot. But it's not done yet. So yes, the container image has been built. I think it should be pushed in there. So of course I'm logged out. Let's go with that. And yeah, you can see, so let me zoom in a bit. And you can see that the image with the tag 002 has just been pushed. You can see the push time, 6:03 p.m. So it's it's the time. You can see at the top you have the time, and you can see that this image from Harbor has already been triggered as vulnerable. So we have 29 vulnerabilities in this image. In SUSE Multi-Linux Manager, you're going to get this result once the inspect in progress is going to be done. So I don't know if it's done yet. Yeah, it's done yet. So now if I'm going back to the image list, that's not true. I should have at some point the first line should be red and not green. So I guess it's going to coming soon. Let me just force the refresh just in case. Yeah, it's going to come at some point. So it finished the scan here. Until it's coming, we can see basically the build logs. So this is when you run a Docker build command, you get the logs, you know. The good things about using SUSE Multi-Linux Manager is that this log will be stored within the database. So if you need to know what was the build steps for a specific tag image, then you will be able to go back in time and to see what was the steps during the build process. Of course, you get, I think it's back now. So let me just go back there. Yeah, you can see that it has been triggered as basically you have update available. So it takes like a minute or two for the system to to get updated properly. So if I'm checking on the patches, right now this is all the patches that are available, and I have 30 patches available. So I have one more that has been detected compared to what Harbor and Trivy have been able to detect. So in Harbor, I have 21. In SUSE Manager, I have 30. You can see the 30 just here. And if you compute here, 13 plus 16, 29, and 1, 30. So you get the patches. You can get the packages that are inside, the image, so you know which version has been installed. But that's one thing. So now, how can I remediate this issue? So doing that automatically, because everything that I did here was kind of clicking here, clicking there, and then going back and forth between windows. So that's fine, but when you are within a GitOps pipeline, you don't want to deal with the UI. You just want to potentially get an alert from the API. So again, SUSE Multi-Linux Manager has an API, and one of these endpoints is basically, do I have errata on this image? And you can have some monitoring saying, okay, I see that this list, this JSON basically list is not empty, which means that I have something available. It could be a bug fix or a security fix. And based on that, if the condition is not null, then you can trigger a pipeline to build a new image. So in that case, I cheated a bit because I know why basically this image has some CVs. It's because I'm using the .7 image. The latest one is the .9. So I cheated a bit, So in order to fix that, I just have to use the latest tag available on the SUSE registry. So here, git add, that's the, just the only nerdy stuff that you're going to see. So just use newer image. Okay, and then git push. And then this should be picked up by my, my actions. So basically, when I do a push within this repository, I have a GitHub actions that got triggered. And this GitHub actions, basically, it's speaking to SUSE Multi-Linux Manager API. And it retrieves the profiles available, the build host available. My script is pretty simple. It's just pick one. So if you have multiple hosts, just pick one randomly, and that's going to be fine. If you want to be more, granular, etc., you can build your own automation. This will be available. It's already available. So if you go on this GitHub URL, you will be able to get access to the Docker file, to the actions and the scripts, etc. So the action is, the GitHub action is done. And what it did is that it triggered normally automatically a build. Yeah, you can see that it triggered automatically a new build for this container. What I expect, it's basically to have a green check mark in the update, 0 patches, 0 packages. This is what we are aiming for. And you can see that the version has been incremented automatically, and again, that it's done part within the GitHub actions. So, you can do whatever you want within the GitHub actions. So, the build is done, then the scan, you can see, is in progress. If I click here, it's going to basically redirect me to the build host that has been selected. So as I mentioned, I have right now 2 build hosts, but my script is just picking one randomly. So it could have been this one, it could have been the other one. That's going to be the same. So I'm checking the event right now on the build host, and if you check in the history, you can see the build basically that happened on this host. So if you have some build that failed, you can just go on the event and check basically what it did, where it failed, etc. Again, it's a formula, so it's some sort commands that are basically triggered. So you can see the Docker login, Docker run, Docker push, Docker logout, etc. So kind of the basic command that you are doing, manually directly on your build host. So Docker login to get access to a private registry, then Docker run or Docker build, depending what you want to do, and then Docker push and Docker logout if you are on a system that you don't want the credential to stay. So in Harbor, I should have normally one more image here available. Yes, so I have one more image with the same tag as the one from SUSE Multi-Linux Manager. And you can see that this one has been scanned, and I don't have any vulnerabilities. And you can see that there is a slight difference in the size, in the image size, which means that packages are slightly bigger, but at least now we have an image that has 0 vulnerability. And that should be picked up as well by SUSE Multi-Linux Manager. I guess I will kind of have nightmare tonight about SUSE Multi-Linux Manager, SUSE Multi-Linux Manager, just me saying that all the day. But yeah, so here you can see that the image has been built, and that's going to be the final status. So we are not going to have to wait for anything about changing the state, etc. It's going to stay like that with the green check mark, 0 patches, 0 packages. And if I'm going to check here, if I go on the patches, nothing is available because no patches have to be applied there. And then on the packages, I will get the list. So if we were like, if we want to push that, deeper, we can compare, for example, versions of packages from this build to the previous one here. So we can go there and go on the packages, etc. And you can compare the list, but that's going to be tedious and not very useful, depending what you are looking for. And of course, I'm going to get the build logs, which is the same. You can just see that at the top here, this is the image that I use, where for the other one, it's going to be the 3.12.7 at the top. And that's it. So it went pretty fast, but this is basically it. So do you have any questions about what you saw or how to set up it, etc.? No? We're good? These are the resources that are available. So I mentioned the container API, and of course, the image build section, which will speak about how to build container image, but OS images as well. You will have access to the Git repository. You already have access to the Git repository, so feel free to fork anything. It's all good. And SLE BCI kind of discovery guide to know a bit more about that. And with that, thank you. No, that's too late.
In terms of, so you made the change to your Docker file, committed it to GitHub. You have a GitHub action that said, oh, new thing, let's trigger a build. Did that trigger, call back to SUSE Manager to do the build, or did it do the build?
So I will show you the action. So this is the trigger. This is the Python script that speak with SUSE Multi-Linux Manager. So this is basic Python, and don't judge me on my Python skill. But basically, I'm giving information about how to connect to SUSE Multi-Linux Manager. I'm retrieving, a cookies, which is kind of a token, and then basically I'm sending a GET request to SUSE Multi-Linux Manager, which is on this endpoint. So system list a system with entitlement. So that's. I will not read the full sentence, but basically I'm looking for the host that has the container build host type on it. I retrieve the list, and then this is what I mentioned. I'm just, if I have more than one, I'm just picking one randomly from this list. And then once I have the list of the build host, I'm just doing some stuff to dynamically increase the tag. You can do that the way you want. And once I have this, basically I generated a tag. And this is the payload that I'm going to have to use during the post. So which profile? That is static, but it can be dynamic depending how you want to do things. So the profile, the tag, which is going to be 00.30, for example. The build host, so the one that we picked randomly. And then just the date that is required for the scheduling. So when do you want to trigger the build to start? And then, so once I have the payload, I'm just doing a post on the image, schedule image build endpoint, and that's it. So basically, I'm retrieving the list of the build host. Once I have that, I'm sending a post, and this is how SUSE Multi-Linux Manager basically got triggered to build the image on a specific host. That's it. And again, it's available. You can use that, improve that, do whatever you want with it. Okay? Thank you.